Hello everybody, welcome into another lesson. So today we are going to talk about the graphs of the secant and cosecant functions and how to graph them. So let's look at the graph first. So here you have the function, the standard form of y equals the secant of x. If we remember, the secant is the reciprocal of the cosine function, okay? You notice the red curve I have going here is the graph of the standard cosine function. So here's the standard cosine function in red. In the black ink, you notice that at the hills and valleys of this function, at the max and minimum values, you have these U-shaped, almost like parabolas. This is the graph of your secant function. It rides the back, so to say, of the cosine function. So whenever you have a positive value for the cosine, your secant's going to go up. And if you have a negative value for cosine, it's going to go down. It's going to be like a downward parabola, and it just rides the back of your cosine function. And then you see these blue dotted lines that these black parabola looking things don't touch. So let's get into that. So in the cosine function, the domain is all real numbers. That's true for cosine. But let's take something like pi over 2. What's the cosine of pi over 2? That's 0, right? Well, the secant's the reciprocal of the cosine, so if we take the secant at pi all over 2, you get 1 divided by 0, which is undefined. And the same at 3 pi over 2. It would be undefined because you would get negative 1 divided by 0. If we did negative pi over 2, you would also get negative 1 divided by 0, which is undefined. Negative 3 pi over 2, you get positive 1 divided by 0, which is undefined. So the domain of the secant function is all real numbers except odd multiples of pi over 2. So like pi over 2, 3 pi over 2, 5 pi over 2, so on. And same in the negative direction. Negative pi over 2, negative 3 pi over 2, so on. All the odd multiples. So now what about your range? We stated that the secant function rides the back of the cosine function, right? That means because the normal cosine function, your range was negative 1 to 1. Well, in the secant function, if you look at the graph, your range is going to be from negative infinity to negative 1. And then again from 1 to infinity. But the values between negative 1 and 1 are not part of the range. You won't get a value between negative 1 and 1. So you're going to have from negative infinity to negative 1, and then it'll skip everything between negative 1 and 1, and it'll be from 1 to infinity. That is the range of the secant function. Now, the amplitude is found the same way. Take the coefficient of the secant of x, just like you would for a sine or cosine. It's the absolute value of that a, which is, in this case, 1. Your period is still 2 pi, so it's 2 pi over the absolute value of that b, which is the coefficient on the x. In this case, it's 1, so your period in this case would be 2 pi. And you see the graph for 2 full periods of the secant function, as opposed to just 1 period, but 1 period is 2 pi. So that's your typical secant function. Now let's go into the cosecant function. It's going to look similar, but it's going to be very different. You'll see how different in a second, even though it's going to look similar. All right. So let's set up y equals the cosecant of x. So this time we'll graph the cosecant of x. let's put this form of y equals a cosecant of bx. Now I'm going to draw the graph real quick, but if we remember, the cosecant is the reciprocal of the sine, right? So let me draw the sine in red ink first. Let's plot the pi points again. Let's do 2 pi. Here's pi. 3 pi over 2. Pi over 2. Of course 0. Negative pi over 2. Negative pi. Negative 3 pi over 2. And then negative 2 pi. Alright, so we have our x points plotted. So now then, let's see, at pi over 2, what's the sine of pi over 2? It's 1, right? So pi over 2, you get 1. At pi, the sine is 0. At 3 pi over 2, it's actually negative 1. Then at 2 pi, your sine is 0. So let's draw the right branch of the curve for sine of 0. Alright, now, at negative pi over 2, the sine is negative 1. At negative pi, the sine is 0. Negative 3 pi over 2, the sine is positive 1. Then at negative 2 pi, the sine is 0. So I'm drawing the graph of the sine function in red. Now the next thing I'm actually going to suggest here is that we plot our asymptotes, which is where the cosecant would be undefined. So let's start at 0. Well, the sine of 0 is 0, but the cosecant of 0, that would be 1 divided by 0, which is undefined. So you actually have an asymptote at x equals 0. And then what about pi? Well, again, the sine of pi is 0, so the cosecant 1 over 0 would be undefined. So actually at pi, you're going to have an asymptote. So let's go ahead and plot that asymptote at pi. And then again at 2 pi, you would get 1 over 0, so you have another asymptote at x equals 2 pi. Alright, and then let's go to negative pi. The sine is 0, so you'll have an asymptote at x equals negative pi. And then again at negative 2 pi, you'll have another asymptote because the cosecant would be undefined there. Cosecant and cosine are definitely not even close to the same function. Alright, so we have our asymptotes plotted. Now, much like with the secant function, it rides the back of the cosine function. So if your sine is positive, then your cosecant graph's going to be positive also. But you're going to get this instead. And there you go. There is the graph of your cosecant function in the black. And we see now, it looks almost like the secant function, only it's the reciprocal of the sine function, so it rides the back of the sine function. So we notice that you have asymptotes at integer multiples of pi, at pi and 2 pi, negative pi and negative 2 pi, and at 0. So the domain of the cosecant function is all reals except integer multiples of pi. So the domain is all real numbers except integer multiples of pi. But the range hasn't changed. It's still from negative infinity to negative 1, and then from positive 1 to infinity. So the numbers between negative 1 and positive 1 are excluded from your range. And your period's still the same. 2 pi divided by that absolute value of b. In this case, your b is 1 because that's the coefficient on the x, so you'd have a period of 2 pi. Your amplitude is the absolute value of the coefficient on that cosecant, so it would be that absolute value of a, that would be your amplitude. Alright, so I think we're ready to do some examples here of some of these. So let's go ahead here. There's going to be a lot of drawing today on this board and labeling stuff because we're going to be back and forth between the secant and cosecant function. Alright. So what's the first one we got? Y equals 1/2 of the secant of pi x. So y equals 1/2 of the secant of pi x. So first let's look for the amplitude. What's the coefficient on the secant? It's 1/2, right? The amplitude equals the absolute value of that 1/2, which means the amplitude is 1/2. Alright, now what is that b coefficient? That b coefficient, of course, is pi, right? So to find your period, you're going to end up taking then that 2 pi divided by the absolute value of pi, which would simply give you a period of 2. So you got a period of 2. So now that we have that as our period, let's label everything. Here's 1. Here's 3/2. Here's 1/2. Here's negative 1/2. Negative 1. Negative 3/2. And then we end up having negative 2. Since our periods are based this time, since our x numbers are based on numbers as opposed to pi. Okay, now we found our amplitude, we found our period. What is the domain of the secant function in this case? Well, it might help if we actually start graphing this. So what is, if we put in 0 for x, what are you going to get? You're going to end up getting, of course, secant of 0, which is 1. Half of 1 is half. So you'll be at 1/2. Now if I put in 1/2 for x, I get the secant of pi over 2, which is actually undefined. So I'm going to have a vertical asymptote at 1/2. Now what about at 1? If I put in 1 for x, I'll get the secant at pi, which is negative 1, times a half. That would actually give me negative 1/2 right here. And then let's say I put in 3/2. So that would give me the secant of 3 pi over 2, which would be undefined. So I have another vertical asymptote at 3 over 2 rather. And then, let's see. Whoops. Let's look at 2. Put in 2, you get 2 pi. The secant of 2 pi is going to be positive 1 times a half would give you positive a half. And then let's just keep plotting the points here. What if I put in negative 1/2? That'd give me the sine of the secant rather of negative pi over 2, which is undefined. So we'll have a vertical asymptote at negative 1/2. Now let's put in negative 1. That would give me the secant of negative pi, which would be negative 1 times a half. That would give me negative 1/2. Now let's put in negative 3/2. That give me the secant of negative 3 pi over 2, which would be positive 1 times a half. No, wait a second. I don't know what I'm thinking. I'm thinking of another function. Secant of negative 3 pi over 2 is undefined. Excuse me. I don't know why I was thinking for a second of the other. Alright. And then at negative 2, if I put in negative 2, that'd give me the secant of negative 2 pi, which would be positive 1. So that times a half is positive 1/2. So now we plotted our asymptotes, we plotted our points. Let's go ahead and produce that secant function, the graph of such. So from 1/2 on up, it's going to be going upward. I'm at negative 1/2 at 1, so it's actually going to go downward. So notice it alternates up and down, up and down. And then at 2, it's going to go to the left like that. It cuts off at 2. At negative 1, it's going to go down again. And then at negative 2, it's going to go up like this. So there is the graph of my function y equals half of secant of pi x. So my domain, again, we know what the domain is. It's all reals except for odd multiples of 1/2 in this case. Now my range, on the other hand, the amplitude has affected the range. What's normally negative infinity to negative 1 would make my range negative infinity to negative 1/2. And then it would also make my range from positive 1/2 to infinity. So the amplitude, you take that and multiply that by your typical range, that'll be your new range. So my range now, because of the amplitude, is going to be from negative infinity to negative 1/2 in union with 1/2 to positive infinity. So that is my range for this particular graph and function. So it narrows the gap between the positives and negatives. Alright, let's move on here. Alright, good one. So we have the cosecant of 2x. Alright, so y equals the cosecant of 2x. So let's look for our amplitude first. What's the coefficient on the cosecant? It's still 1, right? So my amplitude would equal the absolute value of 1, which is 1. So that's easy enough. Now what's my b? That's 2 because that's my coefficient on the x. So that means to find my period, it's going to be take that 2 pi, divide it by the absolute value of 2, and you would get a period of 1 pi actually. So the period in this case is going to be pi. Now we know our period, let's go ahead and label everything. So you'll have pi. Here's pi over 2. Halfway between there is 3 pi over 4. Halfway between 0 and pi over 2 is pi over 4. And we got negative pi over 4. Negative pi over 2. Negative 3 pi over 4. And then we just have negative pi. So there's 2 full periods. Okay. Now, it might be best to actually go ahead and try to start plotting this. So, if we put in 0 for x, what do we get? That'd be the cosecant of 0. Well, the sine of 0 is 0, which means the cosecant's undefined. So we actually have an asymptote at x equals 0. Alright, let's say I put in pi over 4. 2 times pi over 4 is pi over 2. What would be my cosecant? That'd be 1, right? So pi over 4, I'd have a value of 1. Now what about if I put in pi over 2? 2 times pi over 2 is just pi. Cosecant of pi would be undefined. So I'm going to have an asymptote at pi over 2. X equals pi over 2 is an asymptote. Alright, now what if I put in 3 pi over 4? Take that times 2, you get 3 pi over 2. What's the cosecant of 3 pi over 2? That's negative 1. So that's going to go right here. And then if I put in pi, that would give me the cosecant of 2 pi, which would actually then once again be undefined. So we'll have an asymptote of pi. Alright, let's go to negative pi over 4. If I put in negative pi over 4, it gives me the cosecant of negative pi over 2, which would be negative 1. So I'll end up with negative 1 right here. Now if I put in negative pi over 2, that would give me the cosecant of negative pi, which would be undefined. So let's go ahead and plot that nice asymptote right there. Now, negative 3 pi over 4, that would give me the cosecant of negative 3 pi over 2, which would be positive 1. So that's going to come up here. And then if I put in negative pi, that would give me the cosecant of negative 2 pi, which would be undefined. So we actually have an asymptote then once again at pi, negative pi rather. So yeah, these asymptotes are also nice because they help guide the shape of your curves. Alright, we got the asymptotes, we got the points, so let's go ahead. We have a positive 1 here, so that means you're actually going to go up like so to your asymptotes. You have a negative 1 at 3 pi over 4, so your curve's going to go down like this. Alright, then you have a negative 1 at negative pi over 4, so your curve goes down like this. Alright, and then you have negative 3 pi over 4 where it's positive 1, so it'll actually go up like this against your asymptotes. And there is the graph of the cosecant of 2x with all the respective asymptotes. So your domain in this case, where is it undefined? At every single multiple of pi over 2, including pi. So the domain is all reals where x does not equal integer multiples of pi over 2. So that's important to establish. Where x does not equal any integer multiples of pi over 2, that's where it's defined. Otherwise, it's undefined at those points and you have an asymptote. Your range, again, is going to be from that negative infinity to negative 1. Since your amplitude wasn't affected, it's the normal 1. Your range is negative infinity to negative 1 in union with positive 1 to positive infinity. That would be your range for this particular graph. Now I just want to do one more of each, then we'll end the lesson. What do we got next? All right, y equals 4 secant of x. So y equals 4 times the secant of x. So we have that, okay? So let's find our amplitude. What's the coefficient on the secant? It's 4 this time, right? So my a equals 4, which means my amplitude equals the absolute value of that 4, which is also 4. All right, now what's my b? The coefficient on the x, that's just 1. So that means my period is going to be equal to that 2 pi divided by that absolute value of 1, which gives me a normal period of 2 pi. We know the period now. Let's go ahead and plot those points on the x-axis. 2 pi, pi. In between is 3 pi over 2. All right. Here's pi over 2, 0. There's negative pi over 2. Negative pi, negative 3 pi over 2, negative 2 pi. All right. So everything's plotted on the axes. All right. Now, let's go ahead and start plotting some points. So if we put in 0, secant of 0 is 1 times 4 is going to be 4. So we're all the way up here. Now, pi over 2, secant is undefined, so we have an asymptote at x equals pi over 2. All right, now what about at pi? Secant of pi is negative 1 times 4. That'd actually be, well, negative 4. So that's all the way down here. Now, secant of 3 pi over 2 is undefined, so we'll have yet another vertical asymptote at x equals 3 pi over 2. All right, and then what about 2 pi? Secant of 2 pi is 1 times 4. Well, that's all the way up to 4. All right, now let's go to negative pi over 2. Secant of negative pi over 2 is undefined, so there's actually yet another vertical asymptote at x equals negative pi over 2. Negative pi, the secant of negative pi is negative 1 times 4. That's actually going to be negative 4. Whoops, wrong color. Well, at least I have a good marker for where I'm going to be. Okay. secant of negative 3 pi over 2, that is undefined, so there's another vertical asymptote. And then negative 2 pi, the secant is going to be 1 times 4 is actually 4. Alright, so we've got our points, we got our asymptotes. Now let's go ahead and draw our curves. So this time, you're all the way up at 0, 4 where you start drawing, all the way down to pi negative 4. And then at 2 pi 4, negative pi negative 4, and then negative 2 pi 4. So there is the graph of y equals 4 secant of x. Even greater distance between the positive and negative values. Alright, so your domain, it's going to be the classic x not equal to odd multiples of pi over 2. It's defined for all real numbers except odd equaling x equaling odd multiples of pi over 2 where it's not defined. Now your range, that affected, the amplitude affected your range, so your range is actually going to this time be from negative infinity to negative 4. Well, that's actually negative 4 inclusive, to 4 inclusive to infinity. So there is your range for this particular secant function. And I got one more. We're going to do a cosecant function, then we'll be done with the lesson. Find a good cosecant to do. All right, what do we got here for a cosecant? Good one. So we have y equals 8 cosecant of x. All right, well, what's our a? That's 8, right? That's the coefficient on the cosecant term. So a equals 8. That means your amplitude is going to equal the absolute value of that 8, which is 8. So there's your amplitude. Now, what about the period? Okay, well, your b is 1, because that's the coefficient on the x, right? Your b is 1. So your period is going to have to equal 2 pi over the absolute value of 1, which means your period is the normal 2 pi. So let's go ahead and plot that again here. 2 pi, here's pi, so in between that you have 3 pi over 2. Alright, then you have pi over 2, 0. Alright, here's negative pi over 2. Negative pi, negative 3 pi over 2, and then negative 2 pi. So there's everything there. Okay. So it's probably helpful now to start plotting some points. What is the cosecant at 0? That's undefined, right? So we have an asymptote at x equals 0. What about at pi over 2? The cosecant of pi over 2 is 1 times 8. You're all the way up to 8. 8. So there's your 8 right there. Now what about at pi? Your cosecant at pi is undefined. So you actually have another vertical asymptote at x equals pi. Alright, then what about 3 pi over 2? Your cosecant is negative 1 times 8 is negative 8. So there's negative 8 all the way down here. And then at 2 pi, your cosecant is once again undefined. Alright, let's go in the negative direction. So then we have negative pi over 2. The cosecant is negative 1 times 8 is negative 1. So there's negative 8 right there. Now what about a negative pi? Your cosecant is undefined. So you have another asymptote at x equals negative pi. Alright, negative 3 pi over 2, the cosecant of that is 1 times 8, that's actually positive 8. So that'll put you up here. Now the cosecant of negative 2 pi, once again undefined. So you have another vertical asymptote at x equals negative 2 pi. Alright, there's your asymptotes. Now we can go ahead and plot. So up at 8, it's going to be like this. Down at negative 8, it's going to point down. And then here's another one up at 8. And then down at negative 8. So there is the graph of 8 equals cosecant of x. That's quite a spread between the positive and negative values, isn't it? So your domain, once again, is x not equal to integer multiples of pi. So the domain is not defined when x equals integer multiples of pi. So that means that amplitude affected your range, so your range is going to be from negative infinity to negative 8. Whoops, that negative 8's inclusive. In union with positive 8 to positive infinity. So there is your range, negative infinity to negative 8, and then from 8 to infinity. All numbers between negative 8 and positive 8 are not included in your range. So that's it for the standard graphs of the of the secant and cosecant functions. Next lesson we will talk about translating and reflecting them. So I hope everyone has a great day. Take care.